All right. Well, welcome everyone, and thank you for joining us for today's webinar, LiDAR versus Photogrammetry with Skydio 3D Scan, brought to you by Commercial UAV News and sponsored by Skydio. I do have a few housekeeping notes to go over before we officially get started today. If you need any technical assistance, we first recommend you refreshing your browser. But if you continue to have any technical issues, please use the Q&A box and I will respond right away. There is no call-in number for today's session. To connect, all you need to have access to either a computer, tablet, or cell phone for audio, and note that everyone is muted today. For your convenience, everything in the webinar console is fully customizable. So you can move things around, resize the windows, turn on closed captioning. So note that you can customize your console to how you see fit. Note that at the bottom left of your console, you'll find our resources box. This is where you can download the slides from today's webinar. And you can ask questions at any time during the webinar using the Q&A box, and we'll leave time at the end of the webinar to answer as many questions as time allows. And if we don't get to all questions today, don't worry, I'll make sure to forward those off to our sponsor for follow-up via email after the webinar. And finally, this webinar is being recorded today. So you'll receive a thank you email in the next 2 business days from Commercial UAV News with a link to access the webinar console again, to watch on demand and also access the slides again. So please look for that email in the next 2 business days from Commercial UAV News. And with that out of the way, I'd like to welcome our speakers today to briefly introduce themselves. And I think we're going to start with Travis. Welcome, Travis.
Hi, and thanks for having me. So I'm Travis Sachs. I'm the president of 3DS Technologies. I was one of the co-founders that founded 3DS about 7 years ago. When I was in charge of a maintenance department, and someone was in and they showed me this new fancy technology, and I knew right away that it was something that I had to be part of, so I became really passionate about it at that point.
Cool. Hi everybody, I'm Ted. Very similar story to Travis's actually. When I first saw the technology we're going to show you guys today, I became really interested in it, and that was about 8 years ago. So I've been doing a lot of drone services ever since, and I also have the opportunity to teach photogrammetry and some of these reality capture methods at a college level.
Thanks, Ted and Travis. Hi, Alicia here. I have been in the drone photogrammetry space for the last 11 years. I started working as a support engineer for the first drone manufacturer in Europe, or one of the first anyways, that was acquired by Trimble Navigation System. So I was exposed to both photogrammetry and LiDAR from a very early stage of my career. I transitioned into I worked for a couple of DSPs, drone service providers, and then ended up in Bentley Systems, where again, that was the first time that I really understood the value of combining both technologies, photogrammetry and LiDAR, together. And so, yeah, I am very excited about this. Today, I'm working as a principal solutions engineer at Skydio, where I really help our customers, enterprise customers, to, expand their drone programs with autonomous drones for critical infrastructure inspection. So I'm very excited to be here talking about this topic today. Yeah, we actually want to start with a question to the audience. We want to get a sense of, who we have in the room today live. And so, again, I think if you guys are following, and gals are following me on LinkedIn, you saw this post a couple of days ago. Which team are you in? LiDAR, photogrammetry, or both? This has been a constant in my career. I don't know if you guys, Ted and Travis, which team are you in? And this is put you on the spot, but why not?
It depends. It depends what you're going to do with it. That's always the first question.
Yeah, absolutely.
I'm team both for sure. They're both super important in their own way and very useful together.
Yeah, and this is what I've learned in the last few years. Is like it all comes down to what the customer needs, the project requirements. Both technologies have their strengths, their weaknesses. The use cases can be very different for both. I'm just looking at the numbers here and see how we still have like 40% to go. Come on, guys, go back to the screen. Give us a vote in there. But yeah, it's. I was actually looking at an article that I wrote with the same title, LiDAR photogrammetry or both, in 2020, when the iPhone 12 Pro was released. And I'm looking at you, Ted, because I know that you had you did have some experience in Apple. But like it was, for me, it was like just such a disruption that you can carry like a LiDAR on your phone. Like I think that's, in the last 10 years we've moved from when I studied in college, like 13, 14 years ago, a LiDAR was like super expensive, and nowadays it's just much more affordable and accessible.
Yeah, and that's great for everybody.
Yeah, exactly. And it brings, I think that's why this topic is so relevant, because it makes it like, what should I use is more accessible. So like they are both accessible to different projects. Cool. Let's have a look at what we have in the room today. Oh, yay.
I'm surprised by the photogrammetry number, actually. That's higher than I expected.
Yeah.
What are your thoughts, Travis? Did you expect this?
Yeah, I'm surprised by the photogrammetry number too. I think maybe it's just easier to access that technology, so maybe that's why.
100%.
Absolutely. Yeah, cool. Well, we have a team both winning. That's very exciting. I'm going to encourage everyone to use the chat box throughout the webinar. If you've been in a TED and Alicia webinar before, we love engagement from the audience. So feel free to use the chat box, and we'll keep an eye on questions and comments as we move forward. So yeah, I think we're gonna start with the very basics. So for anyone that is an expert in LiDAR and/or photogrammetry, maybe like lay back and chill for a few minutes. We want to just get everyone on the same page. So Travis, let's start with you. You have a lot of experience on the LiDAR and laser scanning. Like tell us, in a nutshell, what this technology is about.
Sure. Yes. So basically, we're going to talk about terrestrial scanning for this webinar. And terrestrial scanners, there's two different kinds. Well, there's more than that, but we're just going to talk about the two different kinds. So there's time of flight scanning, and there's phase shift scanning. The time of flight is more accurate, and it holds the accuracy over the full range of the scanner. And basically how that works is it emits a beam of light, it waits for that light to return, and then measures the distance. And then with that, some of the models can range up to 1,000 meters of distance and hold that accuracy. Phase shift scanners, it emits a phase of light, and then the reflected light that comes back, it measures the time and the distance. And then it gives you a much faster return. It's still highly accurate, but not quite as accurate as the time of flight scanner. And the further away the distance, then you kind of lose that accuracy. And then each point will give you back an X, Y, Z coordinate. And then if you're capturing pictures with that, it'll record that RGB value. So when you're doing terrestrial scanners or scanning, you want to know, first of all, what you're scanning, and then that will help you determine the setup positions. Because it's only line of sight, you want to make sure that you're capturing all of the object that you're trying to capture. So you'll have to move your scanner into different positions to create a full 3D point cloud, which is basically, because you're measuring up to 2 million points a second, you'll want to make sure that all those points that will create that 3D model will cover everything of what you're going to do.
And this goes back to if I can add here, because I think Ted will talked about this I think in the photogrammetry section, but like this comes down to good planning as well. Like before you go on site, you really need to plan this in advance.
Yeah, so you have to know, what, we always say, what are you doing with the scan? So you have to know what you're doing with the scan. You'll have to make sure that you have, a clear line of sight to everything that you're trying to scan. Because you can only capture what you can see, then you want to make sure that you're able to see what you need to. And then so with the registration of that, so each setup position, you'll have a mass of 3D points, and then they'll sort of be individual point clouds, and then you'll want to put them together. So there's different methods you can use for that. Typically you'll want to have some sort of control network that you capture with a total station, or even if you just set up targets. But also with these softwares now, they use lots of algorithms, and they'll use walls, they'll use fixed objects, and they'll try and calculate that registration throughout the whole. So instead of just using single targets, so you might get 100 points with the cloud registration, it'll use all those millions of points and try and match those millions of points to the other millions of points. So it's a much tighter registration. And then, so with that example we just saw, that's 2 different scan locations. And then when you take a very thin slice, then you can see how, how those registrations align to each other.
Yeah, thank you for that.
Yeah.
Sorry that I was advancing too fast.
Yeah, that's okay. Yeah, no, we can talk about this for hours and hours. So trying to share all the relevant information in a short amount of time is challenging sometimes.
Absolutely.
Yeah, so this, again, the first question we always ask is, what do you want from the scan? What are you trying to capture? And that will determine the outcome, because sometimes you don't want to overscan, because then you get too much data, because we're capturing literally millions and millions of points a second. So those data sets can get very heavy, quickly. So we want to make sure we do proper site planning. We want to make sure we capture what we need, a little bit more than what we need, but not too much more than what we need. And you always want to make sure you capture enough. It's always better to need it and not have it than to have it, or to have it and not need it than need it and not have it, because then you'd have to return to site.
And these comparisons, they're all from terrestrial laser scans, so static scans. With I'm seeing some comments about SLAM-based scanners, mobile scanners. Anytime the scanner is moving, like there's more to account for, right? So the true sort of reference comparison here is always going to be terrestrial laser scanning, static scanning.
Yeah. So some of the sources of the errors that you can get is distance, as I talked about with the phase shift scanners. As you move further away, you start getting more noise, range noise, and things like that. If your scanner moves during the scan, some of the higher end scanners like the Leica P series, they have dual axis compensation, so they can compensate for that. But the mid and lower range terrestrial scanners don't have that compensation, so you'll get errors in there. If there's any if there's anything with your system calibrations that's wrong or not up to date, then it gives you false return. Some of the things they're talking about some of the mobile scanners. That data you can actually manipulate. With the terrestrial scanners, you can't manipulate that data. one-to-one. It is what it is. Some of those mobile scanners, you can really run into some big errors pretty quickly if you don't have a really tight control network.
So what you capture is what you get, basically, and there's very little room for improving or changing or that data in the post-processing.
Yeah, exactly.
Yeah.
So in those cases, then you would get the errors from if you don't have a proper registration, and that's where you put the two together.
That's one of the limitations for sure. But like when it comes to where LiDAR shines, and I think this is tell us, Travis, where does LiDAR shine, and where are the the use cases where it is definitely the go-to?
Yeah, so some of the ones, if you're doing really tight or complex environments, dark areas for sure, like if you don't have the lighting, if you have areas like the draft tube shown in the picture, if you can't really send a drone in there or the camera, because it's dark, because it's tight, awkward spaces, sometimes the long range scanners can get places that even the drones aren't able to. And then if you're doing like a large complex site and you need to hold that accuracy, like a whole factory, it's much easier to capture that data with a terrestrial scanner. So it'd be good for that application.
Yeah, I think when I was at Bentley, there was a significant number of infrastructure owner operators that were looking into, the hybrid going from, we have like a, LiDAR, laser scanning for very complex environments, and adding the photogrammetry layer on top of that to create that hybrid model that was ultimately the best possible digital twin they could work with. So yeah, this is a very good use case or example of that, I believe.
Yeah. Yeah, and then as you can see, in terms of the LiDAR, the applications are endless. You can use it for many different applications.
And that list is growing because I think we're starting to see the benefits of certain applications and how much easier this makes it.
Yeah, for sure.
Let's maybe touch base on the cost here. Travis, what could you tell us about the cost of these type of projects?
Yeah, so it ranges, right? You can get low range terrestrial scanner, in the tens of thousands of dollars, and then you can go all the way up to $250,000, and some of the mobile mappers are in the millions. And the difference between those will be the range noise, angular accuracy, things like that, and the speed of the scanner, all kinds of things. And then with the scanner, you also have to take into consideration like the annual calibration costs. And then typically most scanners, you have to purchase a registration software. There are free registration softwares out there, but to get really good results, then you'll want to have one of the proprietary softwares.
Yeah, and I think again, we go back to the project requirements and the customer needs, right? Like, as in, it depends on budget is a key one when we're talking about which technology we're going to be leveraging for specific projects. What's the budget, what are the final requirements in the deliverables, so that will help you decide, do you really need laser scan, do you need what are and what's the budget. So do you find that a lot? Do you find that, yeah?
Well, yeah, and that's one of the things that we help our customers with, because if you just need a floor plan, then you don't need a $120,000 P-series scanner, right? A Matterport might be fine. So there's, it all depends on the application. We always ask, what are you trying to do? And we'll try and help our customers make the best decision And in a lot of cases, photogrammetry is great. It's a great solution. So.
Yeah, absolutely. Let's move on to photogrammetry, Ted. Let's start with the basics.
Yeah, I think most of the audience probably has a fairly good understanding of photogrammetry just because it is so accessible and people are starting to really try it themselves. And that's really the best way to understand how it works. But fundamentally, it's measurements from photos. So in order to make those measurements, we need photos, and those photos need to be overlapping and captured in a very consistent manner. Same distance from surface is very important. That kind of dictates your accuracy that you can achieve, and if that's the same across the entire subject area, then you have a much higher chance of getting the accuracy you desire. But any photo works. In this case, the data you're going to see, all of the imagery was collected with the Skydio S2 Plus, using the 3D scan software that is on the drone itself, and that allows it to take over and do all of the data collection autonomously. I just give it a section, a volume, and it just goes and collects. And both the laser scan and the photogrammetry was done on the same day for this asset. So after you have those photos, the photogrammetry software goes and matches them. Essentially, the unknown is where was the camera when the photo was taken? Where was the drone, and how was the camera pointing when the photo was taken? So that's done by creating first tie points. Those are sort of like fingerprints, like little signatures within each image, and then matching those tie points. And you can see here how those matches kind of correlate to each other. These are 3 images that are captured sequentially. After that's done, we can register those cameras. So it's very similar to how those laser scan stations are registered together, except we're registering images. But how do we get 3D from 2D images? Well, through that process and the densification of those points and more triangulation, essentially, we can extract these depth maps from these images. So essentially, a depth map is like it's still a 2D image file, but it has another dimension there that's usually shown in what can be represented as this grayscale color, and that is just the distance away from that camera.
And
from
similar
there,
to with the laser scan, Ted, I guess that planning your flights is essential, right? Like weather conditions, overlap, like these kind of elements that are going to have an impact on your final deliverables, in the quality of your final deliverables.
Exactly, and laser scanning is an instrument that is very finely calibrated, very accurate from the factory, and it doesn't fluctuate very much. But cameras fluctuate a lot, and there's many models of cameras, many lenses. All of those factors come into play. So it's really about controlling those unknowns as much as possible. So having something that takes some of that work or some of that effort away from the user really helps. And from there you get to what you see here. So the main 2 main derivatives that we see with photogrammetry are textured meshes, which give you this photorealistic surface. And then from that surface, you can extract or sample points. And some photogrammetry engines do this a little bit differently. They kind of skip the depth map and they just make more tie points. In these examples that I'm going to show, I use Bentley Context Capture, or iTwin as it's called now. And iTwin does that route where it goes depth map, mesh, and then subsamples the points from that mesh. So yeah, let's dive into the comparison. Here's the area that we scanned. You're seeing the laser scan, and you're seeing the point cloud from the photogrammetry overlaid on it after I've registered those 2 things together.
So which one is which?
Yeah, so the laser scan is the one that's brightly colored. That's showing you the intensity of each return. So laser scanning can't show you color, but it can show you how how reflective the surface that pulse of light or that phase of light bounced off from, and that kind of replicates color quite well. So you can make out certain details. You can't really use it for inspection, like bridge inspections or structural inspections, but there is some detail there that allows you to sort of conceptualize what you're looking at and see the difference in materials as well.
Yeah.
So for this specific, yep.
No, sorry, I was gonna say I expect that that's already a, for certain projects an advantage on photogrammetry versus LiDAR.
Sure.
You get like after the flight and the processing, you already get like a representation of your physical asset, which you do as well with LiDAR. Excuse me. But you don't have that color in
Yeah.
your final 3D model. Yeah.
Yeah.
You do have the
The
option LiDAR. Yeah, you
Yep.
can add the photograph after,
Mm.
and then each point will have the
Yeah.
RGB value. But it's an extra step after the data capture.
Yeah.
Yeah. And so
Exactly.
the
Yeah.
RTC that we used here has color cameras on it that it aligns for you. So you do get both. The main difference though is that camera that's on the laser scanner, that's not really meant for inspection. It's a fairly low resolution, and it's really just there to help you colorize the point cloud, to give it a more natural look, and also to help you with registration, which is what you'll notice. There's some targets around this building that I set up, and using that camera built into the scanner was how these two things were merged in the derivative that I was aiming for here. So
Do you
for
have
this
a sense
specific
of the time of the capture? Sorry, Ted. Do you have a
time of
sense of the time that you spend on for these two with Leica
so how
versus the
long?
Scadio?
Yeah,
Yeah.
so the laser scanning moved along quite quickly. I think
It was like,
Travis's employee,
yeah, it
like
was
less
about
than
an
an
hour and a
hour.
half. Yeah.
Yeah, something like that. Laser scanning for small sites like this moves very quickly. The photogrammetry was about 2 hours, so not significantly more. But again, there isn't much area here. It's just a lot of dense data collected in one spot. So let's take a look at how we're going to compare these. Basically, we're going to use the terrestrial laser scan point cloud as the reference. That's the ground truth. We're going to assume that is the most accurate representation of that asset that we can get. And then we're going to do two different versions of the photogrammetry point cloud. So the first version is unconstrained, so meaning no controls. Really, the only thing that was there is what the software was able to find in the images and match, and also those stickers that I placed around the surface, and those help align everything. This asset actually didn't really need those stickers, but I put them in there because it really helps bring the laser scan and the photogrammetry data together in post-processing. The other version of the point cloud that we're going to compare to the laser scan is a scale constrained point cloud. So same data, except now we're giving it one reference of scale. And you'll see why that's important, and you'll see sort of what difference it makes. Here's the basically raw unscaled photogrammetry point cloud besides the LiDAR point cloud. So you can see scale is it has obvious errors, right? The house appears to be much bigger than what the terrestrial laser scan dimensions show us here.
And let me just clarify, because I've seen a couple of comments. So just to be clear, the one on the right is the one coming from photogrammetry, and that's unconstrained right now. But we will see another example, which is we've introduced a scale constraint. And then the one on the left is the one you capture with laser scan. And you could have added color to that one as well. Like there's an option to have like a colored. Okay, cool. And then there was I'm not sure you've added this into the example, but like there is a way that you could basically merge these two and create what Bentley Systems calls a hybrid model. So you use the laser scan data and then the photogrammetry together to get the best possible 3D model.
Yeah, yeah. And I have a post on LinkedIn that shows the final derivative of that. But photogrammetry without controls is prone to this scaling error. This isn't a novel finding. This is very well known. So that's why we use controls when we can to reduce the scaling error. So you can see sort of this section from the side of what that scaling error kind of appears to be. It's relatively accurate. The overall shape and size is matches what the house looks like. It's just globally scaled up due to that unknown of exact dimensions from just camera images. To take a look at sort of what the factor of that scaling in this example was from photogrammetry, I did some very basic point-to-point matching here, and it turns out that the scale factor of photogrammetry to get it to match the LiDAR point cloud is about 0.87. So you can think of it as the photogrammetry was 13% scaled up than what it should have been. So
which
that's
is not
version one.
not bad for certain use cases. Like that would be good enough for for what use cases do you think that would be good enough, Ted?
Exactly. I mean, for inspection, that could be fine, depending on what you're looking for. If you're looking for, very general inspection information, you're looking for where the cracks are, where the damage is, an estimate of how much that area is damage. 13% isn't, going to make or break that inspection in a lot of cases. In other cases, it is more critical. So doing something like this is probably what you should attempt first, which is giving it some reference, giving the photogrammetry software reference of what two distances within the scan are. So to do that in this test, I got that reference from the laser scan. So I had two targets, measured the distance between the two targets. You can see here it's 3.8 meters roughly. And I take this measurement and I find those exact two spots in the photos. And I tell it, this is 3.8 meters. So from here on, use this for the rest of the reconstruction. So that should bring everything back down to scale where we expect it to be.
And this is available in most photogrammetry softwares.
All of them. Yeah. Scaling is such a basic thing. Again, it's just a rigid global scale. It's not like we're taking one side of the house and making it slightly larger than the rest. It's just one rigid adjustment. And to do that, I mean, it helps to have a point of reference, a target, something to pick and say, this is the center of the first point, this is the center of the second point. In this case, I used the April tags, which are very useful for many other things. But you can see here that with the photos, you have a lot more precision in picking that point that's right in the middle, because from just a point cloud, you're left with the points that you see. So the intensity and the color that can be added to laser scanning helps, to find where that target is. But there's some measurement error there. Where are you going to click, and where is that exactly the center? And you can see in the photo, it's very, very high resolution, so you can see that center very clearly and click within a few pixels of it.
Yeah, it definitely provides more context as well. Yeah.
Mm-hmm. So now taking those two scaled versions, so the laser as the reference, and then the photogrammetry that use that scale constraint, and doing a quick coarse alignment on those 2 point clouds, you can kind of see how they match. This is just a very coarse alignment. The laser is the green, and the photogrammetry point cloud is the red. So some places they're overlapping, some places one is under the other, etc. And so we can do a little bit more of a finer alignment next, and then we can compare exactly how these point clouds fit within each other. So to do that fine alignment, all of this, this is stuff you can do yourself. And if you have questions on how I did this, feel free to reach out to me directly after. I'm more than happy to show you how. But in a nutshell, we bring in the photogrammetry point cloud, we bring in the laser point cloud, use that as a reference, and then I disabled scale adjustment. So in this alignment process, it is not allowed to adjust the scale of the photogrammetry point cloud, because I'm gonna, I'm saying that I've already handled that scaling in the photogrammetry software. So, a very apples to apples comparison here, straight out of the post-processing. And then here's the result of what it looks like after that final fine adjustments or fine alignment is done. So the point clouds are transformed, moved a little bit to fit as best as possible. And you can see, again, that area of where one is slightly out in front of the other. There's a little bit of deviation, so there's some distance between these 2 points in some areas. Some areas they overlap perfectly, and then other areas the other one. The photogrammetry point cloud is in front of it. Let's take a finer look at this. So I'm taking a cross section, 1 centimeter wide profile, and I'm running down the side of the house here at the corner, and you can see the red is photogrammetry, the green is laser. So these are very close. There are deviations, though. There are areas where the photogrammetry gets it wrong, and most of the time that's because the material that we were modeling might have been metallic, might have had some reflection. Of course, reflections, anything that has that type of surface is going to be very challenging for photogrammetry because it just can't match points between multiple images. But on the other hand, the laser scan also has some areas where it just can't see. It's all line of sight. So having the two together allows you to completely cover all the surfaces and all the dimensions. And so all of these measurements are metric, by the way, so we're looking at millimeter differences between the two. Again, the only thing that was done to the photogrammetry point cloud to get it to here is just a one scale constraint, right? So you don't need to put these scale constraints everywhere. More is probably better, but in this case, just one is what got us to, 4 millimeters, 7 millimeters, 6 millimeters at the bottom distance between the two. And the worst case is at the top there, 2 centimeters. And that's because of that smoothing that photogrammetry can create. And you can see where that smoothing, what that looks like in the model. It's this sort of like melted eave trough, right? That's not really what it looks like. The LiDAR has no problem with that, but the photogrammetry will always have problems with that.
Do you recall what's the GSD for the photogrammetry model?
I don't recall. I think it was in the millimeter range. As you saw, this area was pretty tight, so we had to fly really close to it. So GSD, the spatial resolution of the images was quite high due to that fact that we were so close to it.
And I think you mentioned already, but you use context capture for this specific project, but we use Scadio Scadio data is compatible with most photogrammetry platforms. But I think you're quite familiar with both context capture and reality capture. What are your go-to tests when it comes to photogrammetry?
Well, if I want to take both and create that hybrid scan, I prefer reality capture because it supports structured point clouds in a way that allows me to very fine tune that alignment between the photos and the laser scan. But generally, it's what you're comfortable with and what you're doing. So with photogrammetry, you have lots of options. With laser scanning, you use the software that that scanner supports essentially. At the end of the day, again, it's always what are you after? What's the deliverable? And context capture is what I'm showing for the photogrammetry point cloud here. So the photogrammetry point cloud here has not been merged with LiDAR, or else it would look perfect. They would be, a one-to-one match here. But the reality capture is great to combine them as well. And there's some other software there too. So here's another example. Again, those distances very close, sub-centimeter, 6 millimeters at the bottom, 4 millimeters. And then you can see another one of those cases where the red points, the photogrammetry points, are kind of like melted. It's smoothed across, and it's not really showing the true geometry of that portion of the house here. You can also see an area where the laser scan just didn't see anything. It was in a shadow, so there's no points from the laser scanner there. And that's pretty obvious, pretty evident at the top. That's the roof. So the roof was on a pretty steep slope, and due to that high angle of attack for the laser, we're going to get less points that come back and are registered on the scanner itself. But still enough points in this case to make a surface out of it. And now, so just to sort of show that I'm not cherry picking locations, let's take a look at like a global comparison of the distance between these 2 point clouds. And a wonderful software to do this and it's called Cloud Compare. It's completely open source, amazing software made specifically for this purpose. And it's going to compare the photogrammetry point cloud to the reference laser scan point cloud. And it's not just going to compare to the nearest neighbor, because that distance may be incorrect, but it is going to use some local modeling to essentially create like a surface from that laser scan and measure the absolute distance between the compared point and the laser scan surface. And so this is what it looks like in this color scale. You're seeing the photogrammetry point cloud, but the colors that each point has inherited, the value there, shows us the distance of that point to the laser scan. So Anything in blue is basically zero. There's no distance, there's no delta between the photogrammetry point cloud and the laser point cloud. They're right on top of each other. Anything that's in the red is 5 millimeters or above. There obviously is a lot of outliers here, things like glass and those surfaces that I showed you earlier. I've taken those out of account. I'm looking at anything within a centimeter of each other and how that relates globally to this scan. So you can see very, very close. Like there are some areas where we're seeing that centimeter distance between the two, and those areas are kind of where you expect them to be. They're on that roof. Remember, there's less laser points to compare to there anyways, so it's not directly indicative that there is systematic error or measurement error here, but the distribution is very nice. It really does show that if this is done, with even just one scale constraint and that's it, you can get really, really close. Is it perfect? Absolutely not. There's so many variables in photogrammetry and photos to get this right. But is it good enough for a lot of use cases? I'd say probably. And then here's another example.
Do you see consistency across different, like I know that this example was like a small house. Do you see consistency across different use cases? And I guess it's a good segue for the next comparison with the bridge scan.
Yeah, that's the perfectly timed question, because consistency is key, right? When we're talking about measurements. So with this example, you'll see that the results differ a little bit. And so to just sort of introduce these two data sets, the reference scan, again, this massive scan of this bridge. In fact, Travis told me that this bridge wasn't even what they were there to scan. It just happened to be nearby, and there was enough data that I could use it for this.
So that's an example of sometimes you get more data than what you need. Like we were focused on the area around the bridge, but in that we captured the bridge, and it just so happened that for the purpose of this, it worked out well for comparison.
Yeah, I think I saw you post this bridge on LinkedIn. I was like, oh my God, I have a scan of that bridge too. Can I have that point cloud? Because I really wanted to see this. And again, my 3D scan of this bridge, we weren't doing the 3D scan for the purposes of measurements. We were doing the 3D scan for the purposes of inspection. So no controls were used, no scale controls even here. So this is nothing out of referenced in photogrammetry. So let's see how it compares. So to compare it, I'm taking a small section off the side elevation here of the bridge. There's some things that wouldn't be a good one-to-one representation of the 2-point clouds. For example, in the next slide, you'll see that, and you can see it here too, there's some shadows in the laser scan, right? So it's line of sight. So, Travis had the scanner on the ground and the bridge is up there. It just can't see across there. If you really needed that, you would plan ahead and position the scanner in the appropriate location. But sometimes that might not be possible. And also there was a little bit of registration error here. So I think because this wasn't really the intended target of the scan, this may have been overlooked. I don't think Travis made a mistake in his post-processing. I know he knows what he does very well. But this is I think a pretty interesting example that shows that, this isn't just put the scanner there, hit scan, and you're done. There is, fine tuning. There is some quality control that happens after the fact to get it just right. And photogrammetry isn't perfect either. Even though the drone was able to see areas where the laser scanner may not have been able to see, we never put the drone through the bridge to capture these images and create the model. We're very interested in the exterior for this quick scan. And this quick scan, it was about 3 hours. And so, it was at the end of the day. We had already done most of the inspection, and it was just sort of a test for us. So you can see sort of some of the deformities in that interior section. So when I bring the laser scan, you can see the laser scan is the yellow points and the photogrammetry points together. Again, photogrammetry completely unconstrained. That scale error is still there, right? So again, not shocking. We know that photogrammetry has a hard time with scale. I didn't use scale constraints at all here. So we're looking at a direct output from both. And applying that same alignment to see how different is the scale, how far off we are, we're about 10%. So the scale factor is 0.9. So that means the photogrammetry point cloud needs to be shrunk by about 10% to get it to a best fit with the laser scan. So a very rough best fit. Again, let's look at some sections. I picked this pier here. You can see certain areas, it's right on the money. Other areas, there's a little bit of deviation. There's some registration error here to account for too, so not all of the points are valid, but it shows you that the overall shape and relative accuracy of the scan is pretty close for photogrammetry. It gets it, it gets it to what you would be very, very comfortable with to use in inspections or many use cases or visualizations. Perfect for that. When we take a deeper look, though, at the distances between those 2 points in that section, you'll see that now we're much larger asset, much more distance to cover between the two. No controls at all. GPS with issues that happen environmentally with photos there. So you can see that the distances are now in the 1 centimeter, 2 centimeters. There is a bit more distance between the 2 point clouds, but still pretty damn close. And then for a sort of more forensic analysis, I chose one of the really flat elevations, and this is near the abutment of the bridge. And here I'm showing the distance between points again with the laser scan as the reference. And then in that area on the right there, you'll see that there's some green, there's red and blue. So red means that the photogrammetry points were in front, just slightly in front, and then blue means they were behind the laser scan. So these are assigned distances on this cloud-to-cloud comparison. So overall, it fits quite well, but there are some areas where photogrammetry may have its own registration errors where those cameras were when they were taken, right? So there is a little bit of deviation there. And looking at the distribution of those distances across this area, you see that the distribution is quite tight. It's within. We have a mean of what is that? I can't even. Looks like just under a millimeter. Very close for the most part. But you'll see at the 1 centimeter mark, we're in the 98th percentile of those points. So again, very close. Really depends on what you're using it for, but if you just need it for to have a model, you can pretty much get away with doing it this way, doing it very quickly and having that visual information as well. And then taking a look at a section as well, the whole profile of the elevation, we'll see here that it becomes fairly obvious that the photogrammetry point cloud is stretched vertically, right? So that is not uncommon to see. The z-axis is always more difficult to get right. In the center of the bridge, you can see that the 2 point clouds are well aligned, but on the sides, you can see that the photogrammetry point cloud has less alignment, and specifically less alignment in the vertical. And again, just to look at some distances between the 2 points, we're looking at changes up to a centimeter, up to 10 centimeters in some cases. In the middle here, where that alignment was the best, and that scale is sort of less obvious, you can see that the distance between the 2 point clouds is in the 2 centimeter range as well. Cool. So
that
overall
was a lot of
conclusions.
information.
Yeah. And so if anyone has any more specific questions on like how we do this and how to do it yourself, maybe with your own data sets, like reach out to me. I'll show you exactly the steps involved in creating these comparisons and these graphics.
Yeah, let's go over some conclusions, Ted and Travis. And I think just to wrap up before we go over conclusions, like what do you think? I think you both touched on a lot of the weaknesses and the strengths of both technologies. What do you think that is most the use cases, the best use cases for LiDAR and photogrammetry? I'm going to start with you, Travis, and then we go to you, Ted, for photogrammetry, and then maybe if you can think about what are the key benefits of a hybrid approach.
Sure. I think when it comes to LiDAR, especially terrestrial scanning, it's it's the one you would want to rely on if you want, if you want to be, certainly accurate. It holds that accuracy better. In terms of, I've seen some comments about the mobile scanners. That's a whole different comparison. And I think in some cases, the photogrammetry beats the mobile scanners. So in terms of terrestrial scanning, if you're doing any reverse engineering, if you need, to be certain about your measurements, then, I would stick with the terrestrial scanning.
Yeah, I agree. Yeah, the terrestrial scanning is going to win the accuracy contest every time, right? It's what it's what it's for. I think one of the big things is just, do you have the budget to have both, or in most cases you kind of you stick to one method over the other. It may not be in your business case to dive into one more specifically, and there's a lot to know. So there's also the aspect of, even if you have the hardware, you kind of need to know what you're doing with that hardware.
Yeah, I always say, especially terrestrial scanning, it can seem easy, especially with ones like these RTC 360s. You push a button and let it go. It's easy until something goes wrong, and then it's not so easy anymore. So, having that experience, how to overcome some of those challenges is really crucial.
Mm-hmm. Yeah. Both require a lot of attention. So, I think to get to very accurate photogrammetry, you need to know what you're doing. Less so for laser scanning. There's just the fact that you don't the distances between the scanner and the points, that's it. There's no changing it after the fact. That certainly takes a lot of unknowns out of the equation. But really, it's also the size and shape of the structure, right? As you saw, if you have a fairly small area, photogrammetry can get really, really close. And using controls, using scale constraints, that only improves it. But if you have a really large area like that bridge, you have to take into consideration, is it feasible for me to photogrammetrically scan this entire bridge for the purposes of measurements? That's where you might want to take in someone that can help you, that has a laser scanner that can that can help you, and maybe even merge those two things together for the ultimate result.
Ted, I have a question. In terms of the photogrammetry, if you're scanning, say, a windmill and it has some slight movement, does the photogrammetry compensate for that?
It's a great question. In both cases, I think movement is not ideal. So yeah, any change, a drastic change in the two surfaces will really affect your results. Now, if it's movement of the entire structure, then you're probably going to be okay, because you can adjust the camera position to match that. But that introduces a whole, that opens up a can of worms for both sides. So there's no magic bullet for that.
All right, I'm gonna jump in. We don't have a lot of time left, and we have a ton of questions that we're not going to get to all of them, but we're going to get through a few of them. Just, you can keep entering your questions, because I will send these to the sponsor for follow-up via email. So don't worry if your question is not answered today. I'll make sure to send those over to Scott. So I want to try to get through a couple. Okay, so let's start here. Okay, I have a request from a client for archaeological purposes, with and without tree canopy coverage. What is my best option?
So I'm assuming that relates to aerial laser scanning. That would be, large area, you need to cover it, you have trees, you need something that can look through the trees. That would be laser, of course, right? For the areas where there isn't tree coverage, photogrammetry can work just as well. But it's that the combination of both that is going to be really tricky for photogrammetry.
Got it. Thank you. We have another question. How do you introduce LiDAR into infrastructures where there's no signal or physical access?
no signal, like so we don't need a signal to use the LiDAR and physical access as long as we can, like as long as you can see what you're trying to scan, then you'll be able to capture it. I'm not 100% sure I understand the question, but.
Okay, we'll move on. How do you handle ground control points, and what do you recommend for GCPs on larger surveys?
There's a lot to unpack with how to put controls and how to measure those controls. So the traditional way is GPS, but as you saw on the bridge example there, the question is where do you play, like how do you get a GPS measurements for controls there? So if it is a vertical structure like that bridge or that house, I would probably, if you do want to use controls and known points, coordinates, use something like a total station, right? That opens up another whole other instrument and a whole other set of expertise. Maybe bring a surveyor to do that for you, but it definitely is possible. Like there's always a way to set controls. It's just a matter of doing it in a way that the measurement is going to be accurate itself, because there could be error in that control as well if it's not done correctly.
Yeah, exactly.
And it goes back to the project requirements and the data requirements. Like, do you need absolute accuracy? Do you need relative accuracy? Like, what are you yeah, again, go back to what the customer needs. Yeah.
Thank you. We have a question. What causes the photogrammetry to produce scale errors if all the images have georeferenced metadata?
The answer to that is that the georeferenced metadata in the photogrammetry images is not accurate, right? So in this case, we were using Mosquitio S2+. It does not have RTK capabilities. It's just using its GPS that it uses for navigation on top of its obstacle avoidance cameras. So there's a lot of uncertainty about where that drone actually was in space when it was capturing that image. So one thing I'm really excited for with X10 is the addition of RTK. That will get that positioning of the drone, that prior position, to be much more accurate, right, in that centimeter to centimeter range. And anything you can do to have more accuracy going into the process will result in more accuracy at the end of the day. So that scaling issue should be really improved with the addition of RTK or the differential GPS in a camera system that's flying. So the other side of it is the optics, right? It's cameras. We're measuring from 2D images. If the image is blurry, if the lens is not great, if there's a lot of these aberrations, as we call them in photography, then that's going to translate directly into errors, especially those scaling errors that you're seeing there.
Thank you. We have a question. What is your go-to software for photogrammetry?
I think the go-to software is the software that you can get. Reality Capture just went free.
That's a good answer.
That's huge, right? Like Reality Capture, amazing software, completely free. If your business makes less than $1 million a year, you don't need to pay at all for it. Yeah.
Wow.
So
let me say that Scario is compatible. Scario data is compatible with all photogrammetry platforms that I know of, and I think it depends, as Ted is saying, it depends on the customer needs. Once again, and not all the photogrammetry software are easy to use, intuitive. So it depends on the learning curve, what's the background of the people that are going to be using it, the budget. Do you need very good final accuracy on the final 3D model versus an intuitive or user-friendly workflow, cloud versus desktop. So there is a lot to unpack there as well. Yeah.
All right, we have
and
time
a lot of the
for...
photogrammetry. A lot of the photogrammetry software also is starting to make laser scanning as an input that it will work with and use very effectively. And that's the best part about this, is that on both sides they're merging together, and it's much more accessible.
We have time for one quick question. I think this one's for Ted, possibly, what kind of LiDAR scan would you recommend for use of surveying coastlines to document erosion challenges?
Well, I think there's two options you could take. I don't think terrestrial laser scanning is well suited for that, just because coastlines, to me, that sounds like it's a long area, just a lot of distance to cover, and setting up these stations would take some time. Aerial laser scanning, a lot of LiDAR payloads out there, a lot of LiDAR drones that are perfectly suited for that, are the way to go, is the way to go there. And maybe even handheld if you want to walk that coastline, depending on what the access is like. Both those types, aerial laser scanning and mobile laser scanning, it's not going to give you the accuracy, the millimeter accuracy that you're getting from terrestrial laser scans. But again, I'm thinking you probably don't need millimeter accuracy on a coastline survey like that.
Well, great. Thank you all so much for a great webinar. We are out of time. I did get this question a lot about the on-demand materials. So just a reminder, everyone will receive a thank you email within the next 2 business days that will include a link to today's live webinar as a recording, so you can play back as needed, and also access the webinar slides, and also access the speaker info for each speaker. And you can reach out to all speakers via their LinkedIn. That will be part of the on-demand console as well as your live console right now. So look for that email in the next 2 business days. Also, if you could please fill out the short evaluation form that will appear when the webinar closes, your feedback would be greatly appreciated. And finally, I want to thank all of our speakers today, Alicia, Travis, Ted, for a great webinar, a lot of great information. I know we didn't get to all questions, so just a reminder that I will get those over to Skydio for follow-up in the next few days. Just as a reminder, this webinar was brought to you by Commercial UAV News and sponsored by Skydio. Thank you all for joining us today, and have a great rest of your day.
Well, thank you.
Thank you.
Thank you.